Here.
Wait,
Put it
no,
over.
move it.
No, hand it to me.
He doesn't know that.
Wired.
You forgot
That
to
is
use
how you
them.
spell a squirrel. That is how you spell a squirrel.
Yeah, they are.
Wait, hold on.
Like,
Oh my
You forgot to use.
Okay. Yep, here. This is going to be a teaching moment.
Okay.
Teaching moment.
How do you spell square?
S-U-U-A-R-E.
Really?
Yo!
In serious.
Now, say the word square.
Square.
Now, say the word squirrel.
Squirrel. Find the common denominator. S-U-I-R-R-E-L.
Hey, he figured it out though.
He figured out how to spell squirrel.
Really figured it out.
Third in the class.
You're third in the class at.
Now, people ask me as a teacher, do you have faith in future generations?
Yeah, do you have faith?
No, I don't have faith.
I have very
I used to.
I have no faith in people in general. My generation, my generation, right now.
Dude,
Right now.
He's immediately leaving.
Okay.
You're gonna drop it
All right.
and you're cooking with rice squirrels.
Now that we've figured out how to spell the word spiral, squirrel.
You have pretty good handwriting.
Squirrel.
I need to know that.
Okay.
Hey, at least you know how we should all write.
That's mine.
All right.
Yeah, what's I write?
So-
Right.
So a quick summary. So if you have resistors in series, what do? You add them. Straight up, right?
Yup.
Resistors in parallel,
One over.
1 over. Now, so if you look at capacitors, okay, it's the opposite. So this is what's listed on your equation sheet. So 1 over the equivalent capacitance. So just like you can find the equivalent resistance, you can find equivalent capacitors. So if you need like a 75 microfarad capacitor and you don't have one, but you have different combinations, you can arrange those capacitors in different ways to end up at 75. Just like if you don't have a 75 ohm resistor, but you've got like a 50 and a 25, oh, you can add those together to get to 75. So the same thing can happen with capacitors. So, but it's just like the opposite though. With capacitors in series, you add the inverses of them. Capacitors in parallel, you just add them straight up. Now, unlike resistors who don't store energy, I just can't deal with this whole thing. Give me a second. I cannot give an intellectual lecture and look at the word spiral. So,
If you sound it out. If you sound it out.
No, just stop. Just
Yeah,
stop
you're
trying to
squirrel.
justify it.
even,
Squirrel.
what?
What are the letters that are like right after this?
EQ.
Oh, this is just
You gets a U after
This is just
every
the
single
equivalent
word.
capacity in series. This is the
Every
equivalent
piece.
capacity in parallel.
That's a little.
The
they
S
told
is
us.
in series
Back
and
when we
parallel.
learned how to spell.
That's all it means. Okay, so
I skipped baby. I never learned that. 1 over C.
So when you look at your equation sheet in terms of energy of capacitors, and that's what you're always going to see. Like on this one, you have UC equals 1/2 Q delta V. So just like, that's what the whole point of that demonstration was, is if you don't have a voltage across that capacitor, guess what? You don't have any potential energy stored within it. That's the whole point of it. And Q is going to be the charge that you build up across that capacitor. Now, you also have capacity, the value of the capacity itself is Q over delta V. So, here's where this gets a little bit wonky conceptually, because typically the charge that you build up is a fixed value. So, but because you're dividing by delta V, actually as the delta V gets bigger, what happens to the value of the capacitance? It actually goes down. You would think, oh, as voltage gets bigger. But because of the fact that it's trying to store that charge, so that's why that works the way it does. So there's not a lot of equations that deal with capacitors, but you treat them the same way. So if you said, hey, draw two capacitors in parallel, and the reason that capacitor symbols look like batteries is capacitors basically operate like batteries, but they just charge and discharge very rapidly. And that's one proposal that's been made in terms of like the grids, the stability of the grid. Instead of developing big batteries, you develop big capacitors, so that if you do run into a power outage, then you just do like happened back there. Oh, there's a power outage. You offload the energy stored in the capacitors. Hey, boom, there's your instant power. But the problem is, depending upon how rapidly you want to discharge that electricity, that's going to tell you how long that's going to be available. Okay, so your last assignment on circuits is today. So here's what's going to happen. You all have Monday off. We'll review on Tuesday.
My bad.
Test is on Wednesday. Now, on some of these problems, it's going to be ranking brightness of bulbs. That's going to be one of the things that I'm going to hammer you on the test, where you have bulbs and clusters to be able to calculate power, voltage, current, all of that stuff. Okay? Now, some of these are going to look a little bit wonky, and I'll explain the ones that look a little bit wonky, but you'll see it. So, here we go, kids.
Is that a long assignment?
Not horrible. The beginning of it is worse than the end.
What? That doesn't even make sense.
That's true.
Dude, give it a break.
Yeah, you're not big right.
Hang out.
Yeah, just give up at this point.
I thought there was a short, but
Why did you? For how long did you think scroll was spelled like that, man?
how long have we been talking about this?
Since the dawn of time, bro.
The dawn of
At least, for at least 30 seconds time. For at least
This
30
question
Okay,
isn't exclusive.
so let me give you an example of one. The diagram is a little bit wonky, but it looks much worse than what it is. And this is question number 14. So if you look on 14, and Elliot, I'm going to apologize now for how this is drawn, because it might send you into the corner.
Yeah, I said.
Okay.
14.
Yeah. So it's got a bulb here,
The annoying thing is that would be very easy to draw on
a
Friday.
bulb here, and then you've got a bulb here. Okay. So here, yeah. So don't flip out and go, oh my God, it's a triangle. They're not right angles.
That's a flag.
Okay?
It's a triangle.
I know you don't know about something.
Why is it a triangle?
That's how it is drawn in the book.
Wait, what question is this?
This is question number 14.
Question or problem?
Question.
Okay. Okay.
Real quick, can you search up the flag of Somalia?
You're missing
I'm pretty sure it was, I need it, because then it's like I'm gonna stop thinking about it, I need to verify.
Also, why you're missing a blue?
Let me,
Is that the flag of
Just-
Somalia?
oh, there's another.
There.
Okay.
Oh, there's another problem.
Yeah, so just don't flip out, because like, oh my God, we've never drawn triangles before.
What is everything?
I've never done
represent? I
All
don't,
of these are bulbs.
all of them are bulbs.
This is, all I did was sketch the diagrams that's in the book,
So are they in
just to show you that don't flip out because it's a triangle.
I will.
But think about this, if you remove that bulb, would the whole thing shut down?
No.
No, but if you removed that bulb,
Yeah.
Yeah.
now, if you're not sure, so like on number 14, it says rank the bulbs from brightest to dimmest. So the first one you're going to list is the brightest one. What are you not going to use in between?
Commas.
So let me give you a hint on 14. Only 2 of the bulbs will have the same brightness. Okay?
On 14?
On 14. Only 2 of the bulbs will have the same brightness. Now, the beauty of this is, if you wanted to, there's 2 ways you can verify your answer. One is that you go through and you build this in the PhET simulation. Okay, you can do that. Or you can calculate it. Okay? Now, keep in mind on the test, what are you not going to have?
You never know, Mr. Bird.
Yeah.
Gavin's
If I
Elliot.
remake the PhET simulation in my TI-84, would you allow it?
Why did you ask me?
Yeah, why do you ask that, man? It's not-
That
never
little
calculated.
program.
If you can pull that off, I would let you use it.
Oh! The entire weekend we're gonna code.
And then upload it into that calculator.
Yeah, they had Zoom on that calculator before.
They had Zoom calculator.
Oh yeah, do.
Okay, no, not ChatGPT, like you have to write the code.
ChatGPT does not understand TI base. It does not.
Anyway, so there you go, kids.
Yeah, send me the code.
Yeah, so